Good evening, everyone. So, as per your demand, I am starting again the complex number class 11 mathematics sajidakhtersir mathematics rose. So, welcome to my channel mathematics rose. So, here we are just explaining the algebra of complex number, in which I am discussing first the property of complex number. Properties of conjugates of complex number. As you know that let z is equal to x plus iy. Therefore, conjugate of z is denoted by z bar x minus iy. Okay, so let us suppose there are two complex numbers z1 x1 plus iy1 and z2 is the other complex number x2 plus iy2. Okay, then z1 conjugate is equal to x1 minus iy1, z2 conjugate is equal to x2 minus iy2. Now we will do z1 plus z2. It means that we are just adding these two complex number. So it is x1 plus iy1 plus x2 plus iy2. Now we are keeping the real part together and imaginary part together, but taking iota as the common factor. Now z1 plus z2 is equal to this. So conjugate of z1 plus z2 will be what? This is the real part and this is imaginary part. So this sign will only change. So z1 x1 plus x2 minus iota y1 plus y2. This. Now if we will add here the conjugate of z1 and conjugate of z2, z1 conjugate or z2 conjugate, see x1 plus x2, x1 plus x2, and here if this two imaginary part will be added and minus I we will taking common, so we are getting minus iota I1 y1 plus y2. So from these two equations, suppose 3 and 4, we see that z1 plus z2 sum of the two complex number, conjugate of the sum of the two complex number is equal to the conjugate of the first complex number and the conjugate of the second complex number. So you have to remember this. Proof will not be in the examination. You will have to remember this. So now this is the first property of conjugates. Now the second property, P2 I am writing. Here I am writing P1. Okay. So now second one, similarly you can see Z1 minus Z2 conjugate is equal to Z1 conjugate minus Z2 conjugate. You can see it. Now it is your work P3. Now the property 3 I am going. Z1 Z2 product conjugate is equal to Z1 conjugate and then multiplied by Z2 conjugate. So this. So here we will see this. Say, let us suppose Z1 and Z2 we have already taken as in the previous. It is x1 plus I y1 and this is x2 plus I y2. Now if we will multiply x1 x2, then we will multiply this. So this is I square iota square y1 y2 first, and then this into this we will multiply, this into this imaginary part. So iota x1 y2, and then this is multiplied with this. I am just skipping one step. So iota y1 x2. So here we see that here if you will substitute, this is plus, so here if you will substitute iota square is equal to -1 x1 x2 minus y1 y2, and then here take I common, x1 y2 and then y1 x2. Okay, since iota square is equal to -1. Okay, now we will take the conjugate of z1 and z2, product of this. So here this is the real part and this is imaginary part, so this sign will become minus. So x1 x2 minus y1 y2, which is the real part. So I x1 y2 plus y1 x2, this is coming. This is taken as equation number 1. Now we will find z1 conjugate and z2 conjugate. So z1 conjugate, you know, x1 minus I y1, as we have written in the beginning, and z2 conjugate y x2 minus I iota y2. Now here we will multiply x1 x2, and this we will multiply first. So it is minus I square y1 y2. Okay, so this we will multiply, and here see, after that this and this is multiplied, so minus I x1 y2, and this is multiplied with this, so that it is easy to take I common. So minus I y1 x2. So here put the value of I square. So x1 x2 plus y1 y2, as we know that iota square is equal to -1. Here minus I common, x1 y2 plus y1 x2. So this is coming. Now if you will compare, this is equation 2, and this is this part here this part and this part, means left right hand side of both the parts are same. Therefore this and this, product of two complex number, conjugate of two complex number z1 z2 conjugate, it is equal to individually the product of z1, conjugate of z1 and conjugate of z2. So this is the third property of the conjugate, and we can elaborate it. Suppose P4 I am taking, property 4, z1, suppose z into z into z and so on n times, multiplied by n times. So, and we are taking the conjugate of this z conjugate, how many times? N times. So it is equal to z conjugate to the power n, z conjugate to the power n. And if we will take z to the power n conjugate, z to the power n conjugate means z into z into z and so on n times, and here whole conjugate. So see, if we will take, let us suppose, just say it, say g1, let z is equal to x plus iy. So z conjugate is equal to x minus iy. This, so if z bar multiplied n times means x minus iy is multiplied how many number of times? N times. So it is equal to x minus iy to the power n. And x minus iy is what? X minus iy is nothing but it is x minus iy, it is z conjugate to the power n. And if it is multiplied how many number of times? N times. So this can be written in this way. And again I am taking z to the power n conjugate. So now in the next page I am doing this. See, z to the power n conjugate means conjugate z multiplied by z how many number of times? N times. So now see here, if we will take conjugate of this, so here we have just seen that z1 z2 conjugate is equal to z1 conjugate and 2 z2 conjugate. We have seen in the previous P3 property 3. So it is z1 z conjugate, then z conjugate, and it is how many number of times? Sorry for the throat in is not proper due to cough. So this n times. So if it is multiplied n times, we can write z conjugate to the power n. This, so this is the easy proof. So we can write z to the power n conjugate is equal to z conjugate whole to the power n. So the previous one you have to leave it. So P4, it's a very simple one. And now P5 we have to see that z and z conjugate, it is equal to modulus of z square. So see, z is equal to proof x plus iy. Therefore, z conjugate is equal to x minus iy. And if we will multiply these two, x plus iy multiplied with x minus iy. So a plus b, a minus b, so it is equal to a square minus I square y square. So x square and this is plus y square, since I square is equal to minus 1. And as you know that modulus of z is equal to root under x square plus y square. So if we will square both sides, mod of z square is equal to x square plus y square. So in place of this, from here we can write here in this system mod of z square. So z into conjugate of z is equal to modulus of z square. So this is, so now the uh, video will become very long, so because it is 15 minutes video only, and YouTube says that not you have to make up to 15 minutes video with not more than that in the beginning. So please like, share and subscribe. I will do the other properties in the next video, so don't worry for that in the continuation. Thank you, and please like, share and subscribe my video. And I am getting subscriptions also, and views are also coming, but views is little bit less. Subscription is moderate, so please subscribe. I will start making the video as per your choice, because YouTube is now giving which type of which chapter you are liking video from which chapter in the analytical section. So thank you. Bye bye.